Um, Good morning, everyone. I hope I'm audible to everyone. Okay. I'm Fatma. I will be talking about continuous security testing and sharing responsibility. We'll quickly take a look at the agenda and then we can start. We'll begin with taking a look at what is the current state of security testing. We'll see what a security test pyramid is. We'll talk about sharing responsibility. Then we'll take a look at some real life breaches that has happened. And we'll wind up with some tools and approaches that we can go about with. Before we start, why talk about security? Why should we talk about security? Sorry?
It's important.
It's important, but why is it important? Like,
Because there are confidential data.
right. I think over the years, especially in the recent years, one thing that is more and more common is the kind of data that's available out there, right? That is increased. There's a lot of information about all of us on multiple platforms that are out there that could be very easily misused. I think almost everything is in a place where it is either about to be digitized or digitized, and everything is out there, right? Another precisely why in the last whatever years, few years, if you look at the amount of breaches and attacks that have been there, it has just increased exponentially, which is precisely why if we already haven't started talking about it, we should definitely think about it. Let's look at the current state of security test. Like if you really look at it, there are really just two phases in a delivery team or life cycle that you talk about security. So in the early phases of the project, when you're talking to your clients or whatever, the clients will probably say, you know what, here are some things that are important to me that I'd like to keep secure, or you know what, security is important, keep things secure. And you're like, okay, yeah, you know what, sure. And then in the end, you generally have something called a pen testing or a penetration testing, where you generally have a third-party vendor hired or somebody, where there's a team of pen testers who usually they have a skill set dedicated to finding flaws. So what happens is, this usually happens just before your deadline or your goal line or whatever, and there's only so much that they can do in that little time frame. They'll find bugs, obviously. They will get prioritized, which means some bugs get deprioritized. And when you go live, there are some security bugs, known security bugs that go. Or to make things worse, some things might just not get caught. So that is where we're at, and that is just not right. Right? So we need to change that. So what would be the ideal state? Can we do pen testing a little bit more frequently? Maybe do that a little earlier, maybe, or have it like, I don't know, every iteration or every week or something more frequently, right? Because getting that feedback right in the end might not be enough. People don't get enough time, and you don't have so testers don't get time to test it enough, and it might not get addressed in the right way. So the thing about pen testing is it's a very expensive effort that it is. So which is why it might not be really feasible to have a set of pen testers just testing every time, right? So maybe that, if that is an option, well and good. But if it's not, then what do you do? How do you really incorporate security testing, just like how you have your functional testing, like in a bit more frequent manner, right? So if you really think about it, about how to get there, rewind a few years ago, we had a similar situation with functional testing as well. Not just functional testing, quality in general. We realized that the kind of we have findings a lot later in the cycle. Maybe a lot of bugs are coming after we go live. We need to somehow ensure that these things are being caught early. we need to make that feedback cycle a lot shorter. So, there were a lot of approaches that were adopted to address that issue. Some of those things were TDD, test-driven development. That was one thing where the developers would actually write tests before they even start coding. So things are handled right from the beginning. You don't miss out on anything, right? That is one. Another thing that most of you all will be familiar with is the test pyramid, where I'm sure you have a test pyramid, you have your unit tests, your integration tests, you know what the test pyramid is, right? So that is and there were a lot of other approaches that were taken to address this issue. So what we try to do there is, instead of getting feedback in the end, get that right from the beginning and start thinking about quality of your functional bugs or your functionality right from the beginning and not wait till the end mode. And that has worked out quite well for us, right? That really changed the way we approach testing. So could we just maybe think along the similar lines and just try to adopt those approaches or practices in security as well? So let's take a look at the pyramid. What would that look like? So your security test pyramid looks exactly like your test pyramid. It's not different from your regular test pyramid. But you have your unit test, your integration test, your functional test, and your manual and exploratory test in the top. But the thing about security test pyramid is, the only difference really is that you don't just think about it from a functional perspective, but you also think about it from a security perspective. All the other rules apply here. For example, automating everything as much as you can, putting it in the lowest layer as much as possible, pushing it down as much as possible. All of those rules that you have for your test pyramid, that also applies here. And the responsibility that comes, so you usually have a unit test and integration test written by your developers and your functional test written by your QAs, right? Similar concept, exact same thing. The responsibility has to be shared. Going to the responsibility. But one thing that we really need to understand is security is, it cannot just be one person or one team's responsibility. It has to be something that has to be shared, because it is a vast thing, right? Not one or two people alone cannot just address the security concerns of an entire project. So the responsibility bit can be roughly shared between two groups: the development team and the external community. The development team, just like your regular, like how quality is everybody's responsibility, right? Like your devs, your BAs, your QAs, your entire team, you need to start thinking about it from that perspective. You need to own that up as your responsibility too. That is one. What do I mean by external community? So a lot of security-related concerns and vulnerabilities that have been found, or even approaches to address these problems, have been researched and studied and understood and published. So be it documentations or practices or tools, a lot of people have actually put in a lot of effort, a lot of very smart people, to address these problems. And they've taken up the responsibility of addressing these problems. So one thing that we can do is just leverage that. And we'll get to that part in a bit. So we talked about how security bugs and threats and all of that is something that is common, and we've been finding a lot of them. And what we're going to look at next is, what are some of these threats that we've been finding in the recent past. So we'll talk about some recent threats, what were their impacts, how were they found, and how were they fixed, and so on and so forth. So the first bug or threat that we're going to talk about is an XSS attack on eBay. So eBay, I'm sure a lot of you all must be familiar with. It's an e-com website where you can sell and buy stuff. So, an XSS attack is sort of it's an injection uh, attack really. So what happened? We can not going to get into the details so much. So it's um, okay, before I'll show you an example of what exactly happened, and then I'll explain what an XSS attack is. So what happened is that this is their an eBay website, and what the attackers did was they actually found a way to put this bit into the web page. So how they did, so what would happen is a user who's searching for an iPhone, they would come to this page and they would see this extra 10% off coupon. And what would happen is they'd go and click on it, and it would redirect them to a login page that looked like eBay's page, and they'd be like, okay, maybe my session timed out or whatever, and they'd put their username and password, enter it, and they'd be taken back to this page. So what actually happened was this was not the coupon was not from eBay. It was something that an attacker was able to embed into that page. And how they did it was through an injection vulnerability that was there. So they were able to inject that into the web page. And so the user would not even be aware that this happened. And the attackers nicely redirected them to a login page that looked like the eBay's login page, got their username and password, and then these guys went ahead and purchased. So that was the attack. Now, there's some really so the scary things about this particular threat was the vulnerability called XSS is something that has been found since 1990s. So it wasn't like it was this cool new bug that was there, or something that nobody knew about. It's something that is well known. The next thing is the sensitivity of the information that was stored. If a user's username and password is stolen, basically his whole account is compromised. If so, for an e-com website like eBay, where most people have their cards saved, that can be misused. If not for anything else, you get your username and password, and you can just sell that information itself, right? So, critical information. One of the only things they really had to keep secure, right? That is gone. And if you think about if you ask who discovered the vulnerability, it wasn't eBay. eBay had absolutely no clue that this was happening. It was somebody who just happened to stumble into it, who understood that this is a threat, and this person, since he or she had no what do you say, a malicious intent, they went and reported it, and that's how this thing got found. And to make things worse, this bug was actually there for about 3 months, and nobody really knew. And so another really scary thing about this bug is that it's not just that eBay isn't aware, even the people who got attacked had absolutely no idea that they were attacked. This could have happened to you and me already, and we would still be, like blissfully ignorant about it. So that is one thing that we wanted to talk about. Scary, right? The next threat that we're going to talk about is it's called Cloudbleed. Excuse me for a second. So Cloudbleed was a vulnerability that was found on Cloudflare. Cloudflare is a content delivery system. They provide services like internet security. They provide proxies. They have distributed domain DNS systems and all of that. So the bug was their proxies were leaking out information like your HTTP cookies, your auth tokens, your HTTP post bodies, and pretty much everything that you want to keep secure. So what would happen is data from one customer that they had could go to just about anybody else. And to make things worse, this data was actually even cached by search engines. And so this sounds bad, okay, but what is the impact? Like, how are people like you and me really impacted by something like this? So if you look at the impact, about 2 million websites were potentially impacted by this because they had 2 million customers. And it wasn't just any website, it was big websites like Uber, OkCupid, Fitbit, and even an online password manager. So these are the clients. And if you really look at why the bug uh, was there, right? It's very simple. So what happened is it was basically a buffer overrun. So their reverse proxies have this HTML parser where all requests gets parsed by this guy. And what happened? So what HTML parser usually does is like your HTTP request might get converted to HTTPS, or it might add an Google Analytics tag, or just it might just remove some bad content from HTML request. So that is what a parser does. So in that parser, there was an equality check, which kind of ended up overreading the buffer. And if you really look at what was the root cause, right? There was a in the equality check there was a equal to, and if that had become a greater than or equal to, this bug would have just never existed. The equal to allowed them to actually this thing out of index, and that's how the information bleed. And to make things worse, like this is the most sad part of it, is this is very similar to the, actually almost exactly similar to the Heartbleed vulnerability. I mean, the name is not just similar by coincidence, it's similar for a reason, because the root cause was exactly the same. So Heartbleed was something, again, which had a huge impact. It was found in 2014. I think about, so Cloudbleed was found early this year, sometime in February, I think. This was found 3 years ago. And this was something that also had a huge impact. This was found in OpenSSL library. And the reason was same. It was a buffer overrun. Even then, for some reason, Cloudflare, as big as they were, they missed it. So, and if you really look at the problem that was there, it's something that maybe a unit test could have really caught. Maybe. Now, if that hasn't scared you enough, I'm going to talk about one more one more threat that was there. It's called, so it's one on McAfee. McAfee, if I'm sure everybody is familiar with it, they are the world's largest dedicated security technology. So they made it to the SQL Injection Hall of Shame for 2 consecutive years. SQL Injection Hall of Shame is people who have the privilege of going there are people who make on software as a website where you find injection vulnerabilities that are just so obvious, or that could have been just so easily found or dealt with earlier, that they just like, you know what, you get to go to the Hall of Shame. So then, so somebody like McAfee ended up going there for 2 consecutive years, and that's not a good thing at all. So so what the bug was is the bug was on their VirusScan enterprise for Linux. When there was a test performed, they found 10 vulnerabilities. So there were 10 different vulnerabilities that were there, and they were all pretty bad in itself. But if you combined 3 or 4 of them, they actually resulted in a very deadly combination, and we'll look at what they are. So there was this one. So one of them was that this flaw allowed somebody to an external person to read a file in your system. Now that sounds bad, but okay. So what if somebody is able to read a file in your system? Maybe okay. If it's a confidential thing that's there, then okay, that's bad. But okay, maybe that's not so bad, because they really need to look for something and they need to be able to guess it. So okay, that's bad, but fine. Maybe we can live with it. The next flaw allowed creation of malicious scripts without proper authentication. Okay, that's bad too. Like somebody could actually create, escalate their privileges somehow on remotely and create scripts on your machine. That's bad, but hey, how do they get to execute it, right? So let's look at the next vulnerability that was there. So that allowed escalation of privileges and remote execution of code. So now, Now, if it was just the last one in isolation, they would still somehow need to get the script in that particular system and then execute it, right? But so, which is again bad, but they still would have had to do other things. But if you combine all of these things, it's just like one thing and like handed over in a platter, saying, okay, fine, you go create some malicious script that you want, however, like from wherever you want, you read it, and then you can execute it and do whatever the hell you want with on this person's machine. So that was the bug. So if you really look at it, it wasn't just one individual bug that caused this, like the Cloudbleed one. It was the combination of this thing. So what could have potentially happened, maybe in an end of I'm not talking about this particular one, is maybe they had a pen test, maybe they had found bugs, but maybe the bugs that were being deprioritized, each in itself might not have looked so bad. But maybe one thing that we might miss out on when we're doing this deprioritization is you might not really look at them in a collated manner and be like, okay, you know what, if I combine this, here's an attack. So one of the problems is that we don't really tend to think like an attacker. We think of it like, okay, we need to protect this, We don't really think like an attacker. So anyways, that was the last case study that I wanted to show you. So why do you think these things weren't caught? Because if you really look at all three of the examples that I talked about, they were all known vulnerabilities. XSS has been there since 1990s. The Cloudbleed one, they had found out that there was a similar bug 3 years ago. It still wasn't. So why is it that they weren't caught? It could be the lack of awareness, even though it was known, but for some reason you just didn't know about it. So you couldn't protect yourself from it. Or it just wasn't caught. You did your pen test, maybe in the end of maybe you did. But how much can you expect? Like how much coverage can you really expect at a short time frame, right? So what do we do about this? So so I'll go back to the test film. One thing that you can do is think security test film, right? Think about these things right from the beginning. What can you do to raise your awareness? One thing is just try to keep yourself updated. Try to follow news feeds. Find out what are these common vulnerabilities that are there. How do you tackle these things? You can keep yourself updated, but how much can you do that? If there are a bunch of things that are already known, and there are ways to already mitigate them, can you somehow automate this process? And just like in your functional testing, you have a lot of things that are automated, right? We have tools for security as well that will help you. And I'll tell you why help is in quote in a bit. So let's just look at our, so this is your typical thing in your day-to-day thing, right? Like what you do is, okay, fine. Once you check in, you build your code first. Then you run your unit tests. Then you probably run your integration tests, and you'll run your service tests and your UI tests, right? At these layers, like when these things are happening, can we somehow parallelly automate something? Like if there are some rules that are already defined, can we just use some tools that would just check these things automatically for you? Like for example, you can have static code checkers or dependency checks right at that level. I'll explain what they are in the following slides. So like for example, static code checkers are like, they kind of so there are some industry standards that are good to follow, and they ensure that you stick to it. ZAP is also something that you can do at that level, and we'll talk about it. So all right. So static code analysis, they check if your code really conforms to industry standards. So what they do is they'll tell you when you're writing your code itself, when you're building it itself, at that time itself that, hey, you know what, you probably should take care of these things because this could lead to XYZ vulnerabilities. So they could actually put in place some basic security checks. So even if you miss it in for whatever reason, there's something else telling you that remember this. That's one thing. So some examples of these are taint analysis and buffer overflows. So taint analysis is something that will check the variables that you have in your machine, your system can be manipulated by user input or not. So it actually analyzes that, okay, fine, these this user input could actually manipulate this variable which is used here, and it would actually show you the impact. So that is one thing that is definitely helpful. That could prevent something like an injection. The next thing is a buffer overflow. So something like your Cloudbleed, maybe if they had a buffer overflow check in place, maybe that would have avoided this whole Cloudbleed scenario. Another thing is vulnerable components. So we all meet your source code or your functional test frameworks. They all have dependencies. We have packages, libraries that we're all dependent on that we just usually just import. Like, okay, I need this, I import this. So your code has dependencies, and these libraries in itself might have further dependencies. And these libraries are not really your code. They could have, so even if you write your code like, let's say, super secure, these things could have vulnerabilities, and they might be already known. And somebody would have already gone and like reported this. So we actually have something called a national vulnerability database, which kind of records all of this. So can we? So one thing is your dependencies might have vulnerabilities that are already known, and can we somehow automate that? Like, can you at least have something that keeps checking that, okay, even if you import something, that does the library itself or whatever it is dependent on have known vulnerabilities? And if they do, then that means which means if you find out at least that much, you can maybe find out, okay, what is the next version of this library that's available, or another alternative that does not have this vulnerability. So we have OWASP's dependency checker for that, which will automate this process for you and tell you that, hey, you know what, these packages have these vulnerabilities. Figure it out. Do something. So OWASP is, by the way, an open source community where a lot of security enthusiasts, security professionals all over the world, they kind of collate ideas, thoughts, documents, practices, all related to security. They have tools that they have. So it's a good place for everyone to get started with. Like, so they have a list called OWASP Top 10 vulnerabilities list, and they have their reasons, and something that is very reliable. So they have a dependency checker that you could use. Moving on to, again, another tool by OWASP. So ZAP, Z Attack Proxy. What that does is it's a scanner which you can actually just run against your application, and it has a set of rules, and it will just check that, like, whatever application I'm running this against, does it have all these known vulnerabilities, like threats exposed. So it'll just scan it and tell you. So the thing about this is it's meant to be used by both beginners and professionals. So it's, again, something that's good to get started with. But one thing to remember is it's something that can be configured. It has its own rules. So you might still have to go ahead and customize it, and it's not something you can just completely rely on. Another thing about OWASP ZAP is it can be both at your API level and even from your client side. You can just run it against your application as well. So it's a good thing to get started with. So these are some of the tools that I wanted to highlight. There are a lot of other tools that are there that you can research on and talk about, not talk about, use, depending on the project that you are on. So one key thing to remember, there are caveats on using these tools. So tools, they're supposed to be meant as a guide or assistance. They are not going to automate the whole security testing process for you. You still need to maintain it and configure it, and you still need to use your head to see what is applicable there and configure it accordingly. Another thing, so some of these tools like your Zap can be hooked into your pipeline. So what happens is, okay, you started using Zap and you configured it on your pipeline, and you found some bugs, you fixed them, and now your pipeline is green. Now, when you see a green pipeline, it tends to give you that sense of security, saying that, hey, you know what, we're good from a security point. But that is precisely what we should be aware of. I mean, we should be wary of, because a green pipeline doesn't necessarily mean you're 100% secure. Two reasons. One is your tool is not going to cover everything. So you just because that is green doesn't mean everything is covered. It just means that everything it knows is covered. Another thing is false positives. Maybe maybe what the Zap is, or the tool is expecting, and what is actually what it's telling you is like not really true. It could just give you a false positive. So you need to remember that. And another thing is tools, they require maintenance. They need to be updated. You cannot just, maybe you set it up sometime this year, and 2 years later you just cannot expect it to still run this, and find everything that's new, right? You still need to have it updated and have it configured, because even your application might change. So these are some of the things that you need to remember. So fine. So now we talked about security test pyramid. We talked about how we need to share responsibility. We talked about how we need to keep thinking about security right from the beginning and incorporate it, and all of that. We even talked about some tools. But tomorrow or whenever, when you go back to your project, what do you do with all this information, right? Like now you know that, okay, fine, there's something that you don't know, or something that you need to address. But how do you go about using that, like testing your day-to-day features from a security perspective, right? So for that, we picked a few common features that any application would have, so you have something to get started with. So, for example, uploading a file. Let's say you have to test an application, where one of the features is you have a new feature and you have to upload a file. From a functional view, what are some of the scenarios that you would come up with? Like, what are some of your test cases?
Like, we should see how big a file it can have. That is all.
File format.
Yes. So, when you say file format, what does that mean? Like, what are the things that you would test?
No, we need to check what is the supported by system. We need to see which is not supported.
True. One more? Messages, yes. So, sure, you would test a happy path. You maybe have no file and just upload it. And I'm sure we can go on and on and on. We'll come up with a lot of scenarios. But what if you had to test it from a security point of view? What would that be? What
extension?
Can you elaborate?
Suppose it says Word file, but the extension is something else.
So that's what you said. Like, but how would it be different from a security view? Like, wouldn't that just be your regular functional scenario? Like, how is it a security?
Someone might upload exe file,
Yes.
which can actually run the malware.
Correct. So what you said is absolutely correct. Like, yes, we are definitely going to try like multiple different types of extensions that can be uploaded and that shouldn't be uploaded. But maybe we might not have tried an exe file. Why an exe file? Because
All the malware.
exactly. So that is one thing that you can do. Anything else?
File might have secrets,
Okay.
and the
which is not necessary to be.
Sorry, file might have secret. Okay, so do you mean secrets, or it has something that shouldn't be uploaded?
Yeah.
Content that shouldn't be uploaded. Let's say like a script, maybe, right? A malicious script. Precisely. These are two good examples. So in our day-to-day thing, right? I'm sure these are scenarios that we would cover. I'm sure we would all try uploading things that shouldn't be uploaded, but we would not have tried an exe per se, or excuse me, tried uploading a file that has maybe a script that can be executed later on. So these are some things that we can think about when we're going about in our regular functional test. I mean, regular day-to-day testing. So this is one example. Let's look at another one. Login, log out. Almost all feature. I mean, all websites. Everybody has a login and log out, right? So now, can you think about scenarios from a security perspective for login and log out?
Session data.
5 more questions.
Sure. Sorry.
Session data, like one user's data could be used by credentials.
Yes, fair. And I'm sure there are a lot of different ways to go about it. It might not sound easy, but it's something that, you know what, if you think about, so the thing is, the most important thing really is coming up with a scenario with that, right? Even if you don't know how to go about it, that's okay. If you come up with that, you have Google, and you can find ways, you can always find ways to go about executing it. But the key thing you have to remember is you need to think about it. Just open your mind to it and just try to think like an attacker. That is what else? Like it need not just be even test. Sorry, you were going to say something.
Yeah, password might be some kind of SQL injection, and it can actually penetrate the signing.
It could. So can you maybe insert a script in your password field, right? Sure. That's one thing. So again, another thing to remember here is, sure, test cases is important. That's one thing that we can totally do. Another thing it could just be as simple as asking questions. It could be, okay, just asking your developers, where are you storing your passwords? How are you storing it? Is it plain text? We shouldn't do that. Is it protected? So this is something that you can do. Anything else that you guys can think of? I'm running short of time, so I will give you some scenarios. So one thing is, what happens when login fails? Does it just show you the password somewhere, maybe in the response? Just open your network tab and see. So what happens if you hit back the login? Like you log out and then you go back. What happens, right? There are a lot of scenarios that you can come up with. But the key thing is just try and think like an attacker. From a login page, what is it that an attacker would want to get out of it, right? So one thing, like you said, is try to get into the system, or somehow try to get information out from the system, like without you really have to trying to get into it. One last one, search feature. What?
I can do JavaScript injection.
Yes. So one thing to remember is whenever you see a input box, right? If a user can input something, always think, can I? Because now you're giving the user people access to do just about anything. They can that is their gateway into getting into your system. One way of getting into your system. So an injection is always a possibility whenever there's a text box. So that's always one thing that you can think of. What else? One more suggestion. So again, like I said, think, okay, there's a search box. Is there some way that I can get it to? So a search is supposed to take some input from you and give you some output. Can you somehow manipulate this guy into giving you information that it shouldn't? That is one way to think about it. How you go about it, you can think of it in different ways. You can maybe pull in a developer, ask them how are you implementing it, where who is this search feature talking to, and all of that. And if you understand the system, how it works, maybe you can try to find loopholes over there. So fine, like you said, can I inject something into it? And is there any way to go about getting some data that I probably shouldn't see? So that kind of brings me to the end of all the examples that I have for you. I hope you guys can. So the key thing is really just to think like an attacker. Think about anything that you can extract out from the features that you give your users. So there are a lot of things. It's a huge place, but it's something that you need to get started with. This is something that you need to adopt as your practices as part of your day-to-day development testing cycle. So I'm getting to the end of this presentation. So few takeaways. Regardless of what you're building, you have to be secure. And I think we saw some case studies. We talked about. You gave examples of why it's important to be secure, right? So don't just focus on security in the beginning and end, but try to incorporate it throughout. How do you do that? One way is thinking test pyramid. Then there are tools to help you with this, but just don't solely rely on them. And remember to always think like a malicious attacker. Before I close this, one thing I wanted to talk about is that. So if you really look at the examples that we talked about, right, Cloudly, eBay, NetCafe, none of them really had any. What do you say? They didn't really have any credit cards stolen. Like they have 50 million credit cards stolen, anything of that sort. So one mentality that we all have is that, okay, when we think about security only when, like, let's say there's a payment gateway or there's some really confidential data that you really need to protect. Other than that, you just be like, you know what, it's fine. It's precisely that we need to change, because if you really look at these breaches that we talked about, they didn't really have it. Fortunately, they weren't attacks. They were directed at stealing credit card information. They were random. But for some reason, attackers found a way to, they found loopholes and they found a way to attack. So that is what we need to remember, that it's not just credit cards, it's just very confidential data that you need to protect. It's just, you don't know what information that you have, what little, like Cloudly's example, if you look, it's just such a tiny little mistake, right? That the impact that it had was just huge, right? So that brings us to the end of the presentation. We have some references and some links for further reading, which I will be sharing in a bit. I will take questions for 2-3 minutes. No? 3 minutes.
Okay, fine. 2 minutes.
Questions?
So how does this OWASP ZAP will give us the report on test?
So OWASP ZAP, it has its own rules where it prioritizes some. So it has some intelligence of, okay, you know what, these are bugs that are there. These are vulnerabilities or loopholes that are there, and this is bad, or this is of this severity. This is of this. I'm not sure about the severity, but it will organize it in a way that it understands. And it will show you a report saying that, okay, there is this bug, and I think it also has links to the type of bug that it at least gives you a name, so from which you can actually, at least if the link is not there, you can at least click on Google. But these things are configurable. Like if certain types of bugs are not really important for your application, you don't really care about it, or it's not applicable for you, you can just turn that thing off, you can comment that. Yeah.
So, ZAP has specifically two types of scanning that it does. One is passive, one is active. Passive scan is where you've already intercepted it, you've seen what kind of APIs and calls that are being made. And there are some rules, as she's saying, that ZAP already has that it tests against, right? For that, that is possible on any website that you're hitting, and you can, get a result out of that. If you're going for an active scan, that is where injections happen. So passive is only where it is, reading the calls and trying to run some tests against it. Active scans are where it's trying to put something back into the website and trying some test cases around that. So based on whatever you have selected to, run as your test, it gives you results accordingly. And for each one of them, as she's saying, for your project, it's very, very subjective actually. For some projects, maybe it doesn't make sense to even test for, let's say, XSS or injections or something. You probably don't have a backend, you don't have a SQL, right? So you will not test for SQL injections. Maybe you have a NoSQL, you test for NoSQL injections, right? So all those things are configurable. You can actually add your test. You can say that I don't want to test for SQL injections, don't give me results. It's a waste of time and resources and everything, right? So all that is configurable. Even the severity priority that goes with your project, even that is configurable. So you could, so you get results, reports accordingly.
Any other questions? One more? No? You good? Okay, I'd love to hear some feedback. Please do put some on the board. Thank you.
Thank you so much for that. It was really insightful and will help us think in terms of security at every point in the project.
Thank you.
Also, please, like Fatima said, please do provide feedback about the talk and about the event.